Hi, my name is Sai Deepika Chandragiri, and today we are going to discuss about one of the interesting topics of the physics, that is gravitation. So, why we have to learn about the gravitation? What is gravitation mean? Let's see. We all getting the doubt is that what is gravitation? Okay, next picture. Here is a picture about the Earth and the arrow marks towards the Earth. Why it is showing this? Is there any relation between the gravitation word and this picture? Might be. Let's see. So here there is an Earth, and we all know that is a planet, and the arrows are revolving. The arrows are showing towards the Earth. What does it mean? Let's see. And next, did you notice this? What? Have you ever wondered how can we walk on the ground freely? So here one doubt comes into the picture, that is, we all know that there is an optical shape or oval shape. Uh, Here, when we walking on the road and traveling on a bus or any vehicle, we are feeling that the Earth is in a flat surface, but it is revolving around the sun and revolving around itself. Why we are not falling down from Earth? Is there any interconnection between the topic gravitation and this one? Maybe there should be some relation between these two. Okay, next see, so here another one. When a fruit falls from a tree or something drops from a height, it always heads for the ground. So here there is another notice, that is another observation. When the fruit is falling from the tree and it always reaches the ground only, it is not moving upwards. Why it is happening? Did you notice this anytime? Let's see. Is there any relation between this and the topic case? Once upon a time, there is a great scientist named as Isaac Newton. He is one of the greatest scientists in total world. So one day he sat under the tree, whatever the tree is. For example, we are taking an apple tree. One apple is fallen from the tree, and he that touches his head and moves towards the ground. He thought that why it is happening, that apple is why it is falling on me, and why it is not falling towards the sky. There this topic comes into the picture, that is gravitation. He started investigation why it is happening, and why it is happening. So there he invented the concept, that is gravitation. In simple words, the gravitation is the force operating between the two objects on the earth, any thrown object. So here simply I will explain about this slide. So here one person is there, one person, that is, or that person is an object and the ground is an object. There is a interconnection between these two, that this object is attracted towards this ground. Why it is happening? Because our earth has a gravitational force. This is that is why we are not falling away from the ground. Next comes to the tree. In this case, the apple is falling towards the earth, not towards the sky. Why? Because the earth has a gravitational force and it is attracting towards it. Next. So this is a simple examples and the definition for the gravitation. So simply it can be taken as like this. So here the scientist Newton invented this. So that is why it is called as Newton's law of gravitation. So as a science student, the theory is not important. We have to prove that practically. Then only the world believes that this is a great theory. So for that, we have to prove that what is that force, and what are the components for it. So here there are two objects. Generally, the forces between the two objects no. So simply we are taking, for example, not only two objects, but many objects also. So here we are taking the two objects, that is Earth and Moon. We are giving the masses of there as m1 and m2 respectively, and the distance between them is r. Here the formula comes into the picture. How means we can see now. So here let's assume that the force between those two bodies, that is m1 and m2, maybe p and q, whatever the indication we can take, so that F is directly proportional to the product of their masses. That mass should be M1 or capital M or P or Q, whatever it is. We can take like this. Here the proportional means when the force increases. Force means attraction force. That mass of the two bodies also increases. That is the meaning for the proportional. This can be taken as equation 1. And second, the force is inversely proportional to the square of the distance between these two objects. That is, force is inversely proportional to square of the distance. So here, what is inversely proportional means, and the force increases, the distance decreases. This is taken as equation 2. We combine equation 1 and 2, then we get F is directly proportional to product of their masses by square of the distance, that is r square. Or here we can remove this proportional by using the proportionality constant. Here that is capital G. What is capital G? Further we can discuss about the capital G. So here the finally the formula is F equal to capital G product of masses by r square. So finally by default the formula is F is equal to capital G into m1 m2 by r square. Here m1 m2 that value might be anything. Is it a b or a capital and small m, whatever it is. Here F, where F is a force and G is a gravitational constant and m1 m2 are masses of the bodies, and r is a square of the, r is nothing but the distance between those two bodies. Here there are two types of G's present. What is the difference between capital G and small g? Why we have to learn about this? Okay, first see about capital G. Capital G is a gravitational constant. The name itself indicates that it is a constant. So it has a constant value. That means it doesn't change anywhere. So its value is 6.61 into 10 power minus 11 Newton meter square per kg square. So Newton meter square per kg square is the unit for this gravitational constant, and it is a scalar quantity. So I already said it remains constant always and everywhere. So this is constant everywhere. So coming to small g, what is small g? So for example, the Earth is revolving around the sun and the Earth is revolving around the around itself only. So for that there should be some acceleration. It is not stable, no. So there should be some acceleration. Why it is coming means because of gravitation. So the name small g indicates that acceleration due to gravity or gravitational acceleration. We can call it as our comfort like this too. And it has also some value, that is 9.8 meter per second square, but it is not it varies at various places, and that means it changes from place to place, from maybe the state to state. It is a vector quantity, and here the meter per second square is the unit for this small g. Next, so what is important of universal law of gravitation? So it is an important part of theory of gravitation. From this theory only, the total gravitation and etc., the rocket science and the satellites, everything comes to the picture. So the basic thing, this one is gravitational force is responsible for binding us on Earth. Why we are not falling away means it is binding us to the Earth. It is attracting towards the Earth. So next up, it is the reason behind the motion of the moon around the Earth. So we all know that moon is a subplanet for the Earth and it is revolving around the Earth. Why it is happening means because of the gravitation only. Planets revolving around the sun because of the gravitational force only. And we all know that oceans and seas have tides, and the heights of tides varies from time to time. Why it is happening is because of the gravitational force only. Next, in some of the important points about this, that is it already said this one, planets are in the sun, tides is okay. Next, when an object falls from any height under the influence of gravitational force only. So when we thrown any object towards the sky, it comes back to the ground only. Why? Because this is acceleration, because of acceleration due to gravity. It is denoted by small g, and acceleration due to gravity. Those two have the same units, that is meter per second square. Okay, this is the end of the concept, and thank you so much for giving me this opportunity.